It is my honor to introduce the Orion crew for this first mission to land humans on Mars. These 4 brave astronauts are Commander Benjamin Chambers, Flight Engineer James McCormick, Mission Specialist and Lead Scientist Courtney Sanders, and Lieutenant Commander and Pilot Lucy Anderson.
We, NASA, we are going to the moon and on the Mars.
And then a machine that goes chugga, 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 chug, and then you go to the galley and you make yourself a cup of coffee.
50 years ago, we pioneered a path to the moon. A trail we blazed, cut through the fictions of science, and showed us all what was possible.
Research, scientific research.
Today, our calling to explore is even greater.
You are thinking it is.
To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations.
Even recycle our urine.
We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity.
I want to do some physics demonstration.
Going to the moon, to stay, by 2024. And this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
this system is capable of being the catalyst for deep space missions
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon. Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable, that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified from water, and separating oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us
Congratulations, Orion. You're now successfully on your way to Mars.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system. This is the next chapter of human space exploration.
Preparing to exit low Earth orbit.
Humans are the most fragile element of this entire
You need to
endeavor.
reach 25,000 miles per hour, break out of low Earth orbit at an altitude of 1,270 miles.
Knowledge and understanding, and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are not going.
We're not going.
We are not going.
We are not going.
Not going.
No, we're not. No, we're not going.
Yay, yay, yay.
Technological lost generation. Technological everyone dies. Technological black person. Technological 1990s. Technological lost generation. Technological everyone dies. Technological black person.
I got a bungee
everyone
spread
dies.
across the
Technological everyone
hatchway.
dies.
Serious
Technological
research,
everyone
scientific
dies.
research.
Technological everyone dies. STEM fields. All the STEM fields. Kind of smug. Wow, look at that. Kind of smug. Wow, look at that. I stand up in front of an 8th grade class and I say, it's flowing. It's going. So I stand up in front of an 8th grade class and I say, it's flowing. It's going. Science, technology, engineering, and math. Smart people, go for it. Mine is about to grow. Let's do this. Science, technology, engineering, and math. Smart people, go for it. Mine is about to grow. Let's do this. Let's go to Mars so we can do science. Let's go to Mars so we can do science. Time for vodka so we can do science. Lucani so we can do science. Let's go to Mars so we can do science. Let's go to Mars so we can do science. Big fat one so we can do science. So we can do science. Let's go to Mars so we can do science. Let's go to Mars so we can do science. Time for vodka so we can do science. Lucani so we can do science. Let's go to Mars so we can do science. Let's go to Mars so we can do science. Big fat one so we can do science. So we can do science.
Actually, not too bad.
There's no point using our fuel.
Rotating 360 degrees.
What are you doing?
Ocean landing.
Its rotation is 67, 68 RPM.
Achieve enough margin to bring it all the way back to land.
It's not possible.
When something is important enough, you do it even if logs are not in your paper. This may sound corny, but love is the answer.
no time for...
There are many, many simulations. These simulations are, we might as well call them reality, or you could call them multiverse.
No controls touched at any point during the entire journey.
And it's still tripping me out. I mean, I'm tripping balls here.